Okay, yeah, no, that makes sense.
All right, so let's stay focused here, guys. We have a lot to do, and we all want to do well on this quiz. So we did page 1, front and back. We did that the other day. Now we're ready for number 9. So this is another one of these. You know, we've done some before. We're selling something. We're going to change the price, and of course, as I change the price, that changes the number that I sell, right? So, how do I calculate my income? In problem number 9, my income is calculated how?
Money, ground sold plus revenue. Times
So it's going to be the number sold times the price each. Number sold times price each.
Oh.
Isn't that how I figured out?
Yeah.
Yeah.
All right, so how many do I start out selling? 100. But what's happening to that number?
Minus 10.
It's going down in increments of 10. So it's 10x. And then, how much am I selling them for originally? $5. But that's going up in increments of 1x, right? $1 per x.
Yeah.
So if I FOIL this out, this will be a quadratic opening down. I don't know, I've made 18,000 mistakes today already. I don't know, does that look okay?
Yeah.
Now read the last sentence. I want to maximize. What does that mean? I'm looking for the vertex, aren't I? Because isn't this a parabola opening down?
Yeah.
That's the point I want.
Right.
X equals, how do I do it?
50,
Negative B
Negative B over 2A.
over 2A. So 2.5, 5 halves. Now, that is the number of increments, right? That's X. So it says, what should I charge? Well, right now, I'm charging $5, $7.50. So 5 plus 1 times 2.5. So I should charge $7.50 to maximize my income. You all right, Garden?
Yeah, she had something to stuck in my eye.
Okay, you okay now?
Yeah.
Okay. All right, now we're sketching.
That's not what you're saying.
All right, we got a bunch of practice problems here. So let's look at the first one. What are some things that are going through your mind right now?
3 is the highest. That's what it's going to be.
Even.
Oh, 7.5.
Oh, it's going to be opposite. It's going to go up.
So we're gonna have an x-intercept of -2.
Positive 3 and positive 5.
Perfect.
And the 3 is nothing.
And the 3 is just there. It's going along for the ride. Yeah. Okay, is that good with everybody? Then I heard somebody over here say, all together, I have 6 x's. Would everybody agree with that?
Yeah.
That is an even number. Evens are up, right? So this guy is starting up here and he's coming down to that point. Then you gotta look up here. That came from here, agreed? That is squared. So this is going to bounce off. And then it's going to connect to this one. What's it going to do when it gets to that one? Just go straight through. And it's going to connect to this one, but I kind of have to plan ahead a little bit because that means I'm going to have to squiggle. So I'm going to go ahead and draw my squiggle and then kind of connect it. So it's going to look like that.
I can't figure out how to draw a square.
Is that okay with everybody?
Yeah.
Same thing for the next one. Let's get our x-intercepts on the picture. Those are kind of, I mean, you need those points, so let's get them on there. We got one at -1. We got one at 3. And we got one at -3. So far, so good, men and women? Let's count them up. Elijah says it's even as well. Is he right?
Yeah.
X to the 4th. So we should be doing what this one did. But we're not because that number happens to be negative. So it's going to come in from the bottom. Now be careful. Where did that dot come from? Here. So it's going to bounce down and connect. That came from that, so it's going to go straight through and connect. That came from that, so it's going to go straight through and be done. Are we good, folks? Got it? All right, the last one is a little bit trickier. Why is this one a little bit trickier? It's not factored. So we're going to have to factor it. So what do you think when you look at that?
Well, X
So
squared.
factor it by grouping. So x squared, x plus 4. Minus 4, x plus 4. Everybody still following along okay? Your quiz will have one problem that's already factored for you, like this one, the other one we did, and it will have one that you will have to factor. All right, so we've got x plus 4, x squared minus 4, and what do we know about x squared minus 4? Plus 2 minus 2? What's the matter, Tanner?
Never mind, I got it.
No bouncing or anything in this problem.
Nope.
So we'll just put the -4 on there and the -2, labeling our points. Please label them so I don't have to take off for stupid stuff like that. It's a cube, so where's it going to start? A cube is going to start down, connect, connect, connect. There you go. Nothing fancy, it just passes through and connects. Okay? All right, now 11 is the backwards of that. 11, you've got the picture, and you're gonna build the equation, so we're working backwards. So, I know my picture is going to have 3 parentheses. Can somebody tell me how I know my picture is going to have 3 parentheses? Sam?
I was gonna say because there's like 4 points on the graph.
There's 3
On the X.
x-intercepts. And the factors come from the x-intercepts, right? So when you got this thing factored, the first thing we did was put those 3 dots from these 3 parentheses, right? Now I know there's another point in there, but that doesn't go in a factor. That's for something else. What's going to go in the factors? X plus 3 minus 1 minus 4. And then
X plus 3.
I'm going to look really carefully at what that curve's doing. What's it doing right here? Bouncing, so that one's got to be squared.
Does it matter what order?
Nope, it's in any order. So this just goes straight through, and this one also bounces? Gotta pay attention to that. Now there's only one thing missing, that would be done. That would be done, except for one thing, what am I missing? The coefficient out in front. Whenever you build your own equation, you need to find that coefficient. All right, now, how will I find that coefficient? Well, remember that other point Sam noticed? That's an X and a Y. So I'm gonna put negative 10 in and 2 in. Now, you gotta pay attention to those squares, because they come into play here. So negative 10 equals n times, okay, 2 plus 3 squared,
5.
2 minus 1, and 2 minus 4 squared, 4. So negative 10 equals 100 and, this is all multiplied. Multiply all that together, always times, times, times. So n equals negative 110. The answer to the question is not negative 110. It's this with negative 110 out in front of it. You are writing the equation. So this is what you're going to put in the answer blank. Does it make sense that that would be a negative 110? Does that make sense?
Yeah.
Yeah, why does it make sense?
You start.
Because the picture's upside down, right? Picture's upside down. All right, one more. Number 12. A stone is thrown upward so that its height above the ground is given by this equation. I don't know what that last number is. I'll make up a 12. I'll just say 12. I don't know what it is. Let's say 12. Now, before you start freaking out, I want you to make 2 observations. See the word maximum in there, in the problem? What is this? It's a parabola opening down. And the question is asking me something about a maximum. Obviously, what do I need? The vertex.
No, Joe.
And how do I find the vertex?
Opposite.
Could I find it on my calculator? Yes. But it would probably be faster, frankly, to not use a calculator. How do you find your vertex? X equals negative b over 2a. So 2. Now, what is the actual question? When does it reach the maximum height? In this problem, I used x here, but in this problem, my x was really a t. So t is 2. When does it reach its maximum height? After 2 seconds. What if it said, what is the maximum height?
Plug 2.
Then you would plug 2 into here and get your y coordinate, right?
That point was using the calculator.
Okay? Now, I wanted to do a little bit more review than is actually going to be on the quiz tomorrow, so I'm going to focus you now. All right? So what you're going to, we're moving on. We're not reviewing anymore, we're moving on. But the problems on the quiz tomorrow will be a problem like, number 1, number 2, number 5, 6, 7, and then 2 graphs. I already told you. One where I have factored it for you, and one where you have to factor it. All right, so one more time. The quiz took Monday. 1, 2, 5, 6, 7, and then 2 of the graphs, where I give you an equation and you graph it. One of the equations we factored already, and the other one you will have to factor. Okay? No calculator. That's what the quiz is over. Now, come test day, all this will be there. That is all the quiz is over. All right, so now it's time to get our notes out and we're moving on.
I don't like it. I totally put it in. Wait, that one's not on it? My finals coming today. My binder's coming today, so I ordered it this year. So good. I know, I think that. Yeah, I'm going to
All right, so 2.4
It's like pink. It's like cancer. Oh, yeah.
starts out with long division practice.
Oh,
I know, I do not like long division, but we're gonna practice just because we need it. All right, and we'll talk about, as we go through this section, we'll talk about when we have to do long division. I wouldn't be doing it if there weren't times I had to. There will be times we have to do it, so we're just practicing it. All right, so we're gonna divide long division. We're gonna divide x minus 1 into this. Now, I want you to pay attention what I wrote there. Did you catch that? What did I sneak in there? Why did I put a 0 in there? Because I have to fill that spot, right? I have to fill that spot. Now, you can think about this lots of different ways. One way to think about it is, what do I have to multiply times x to get x cubed? X squared. So I'm putting x squared up there. It really doesn't matter where you put it up there. I like to keep things lined up just because that's the way my brain works. But as long as it's up there, it really doesn't matter where it is. Now, take x squared times both of these. So x squared times x is x cubed, and x squared times negative 1 is negative x squared. Would everyone agree with this so far? Now, remember, with regular long division, you would put a 4 up here, and then what would you do? Subtract. So that's where we're at now. We're going to subtract. And subtracting means changing all the signs. These will cancel always. You planned it that way. That's why you put x squared up there. But now you have 5x squared, and bring down your 0. So now I need to multiply, put something up here. So when I multiply times x, I get 5x squared. So 5x. So 5x times x. 5x times negative 1. Everybody good? So now I'm going to subtract. These will be gone again. And now I have 5x and bring down my 2. Alright, start over again. I need to put something up here so that when I times it by x, I get 5x. Okay. So that'll be 5x minus 5. So I'm going to subtract. And I got a little 3 left over down here. And I'm done dividing. That's my remainder. So up here on the top I'll say plus 3 over x minus 1. And there is my answer. Alright, let's do one more long, and then we're going to practice synthetic, which is so much more fun. So x squared minus 2, x to the 4th, 2x cubed minus 2x squared plus x. minus 3.
It's 4x squared.
What?
Are you on B?
I'm on B.
It's 4x squared.
Oh, 4x squared. Thank you, Dana. That's like my 18,000th and first mistake today. I don't know, something's not working right, guys. Might be getting too old. Alright, how's that look, okay? Alright, now, how many times does x squared, or what do I need times x squared to get x to the fourth? X squared. So again, put it up there wherever you want, I'm lining it up. So I have x to the fourth. Now be careful here. My next one is gonna be minus 2x squared. So I need to bring that over, because I'm gonna be subtracting like terms, right? So here we go. So those are gone, but look, now I've got 2x cubed minus 2x squared plus x minus 3. I'm gonna bring everything down. You don't need to bring this down if you don't want to. That's a big issue. Are you with me? So now we start over. Okay, I got x squared. I need a 2x cubed. 2x. So I get my 2x cubed. But now I have minus 4x. Don't put it here, because you can't add those. Put it here. So negative 2x squared plus 5x minus 3.
Multiply by
Need a negative 2. Negative 2. So I get negative 2x squared plus 4. So I'm left with 5x minus 7. Is that what you're left with? And that is my remainder, so I'll say plus 5x minus 7 over x squared minus 2. As we proceed through the unit, a division like this we'll be doing synthetically, because we're dividing by x minus 1. And as long as you're dividing by a plain x, what we call a linear x, plus 5, x minus 7, whatever, you can do it synthetically. This one would have to be done with long division, because we're dividing by a quadratic. Okay? If you're dividing by a plain x, you can synthetic. If you have to divide by something else, it has to be done. All right, let's practice synthetic. Remember how to do that? Oh my gosh, it is so much easier. I use a little box. I don't know what your teachers last year used. And in this little box out here, I'm going to put a 2. Anybody know why I put a 2 in that box? I'm dividing by x minus 2. And whatever you're dividing, did you guys do this last year?
Yeah.
Whatever you're dividing by, the opposite of it goes here. So in the next problem, in problem B, in the box I will put a negative 1. Then I write down all of the coefficients of the problem. So I have a 2, a 4, a negative 1, and a 1. I leave some space here, draw a line, and this number comes straight down. Whatever it is, it can be anything. And then 2 times 2, write the answer here, add. 2 times 8, write the answer here, add. 2 times 15, write the answer here, add. now what in the heck is the answer? Well, this started out as 2x cubed, right? So now it's gonna be 2x squared plus 8x plus 15, and what's that guy? He's the remainder of the problem. So when you divide, this makes sense. If you have an x cubed and you're dividing by an x, you're gonna have x squared, right? There they are.
When can you not use?
When you're dividing by something that's not a plain x. So x squared would say I can't do it. If that were an x, I could do synthetic. All right, next problem. You already told me out in the box I'm gonna put a -1. But caution, 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 Elijah said you gotta fill in some spots here. So I'm gonna start with my x to the 4th, 1x to the 4th. I'm gonna have a 5x cubed, but a 0x squared, a 0x, and then a -8. You have to fill in zeros for any missing powers. This is question 2B, Joe. I think you might be on the wrong page. You already do it?
Yeah.
Okay. All right, so here we go. Everybody ready? Got set up? Bring the 1 straight down. -1 times 1, write it here. Add. -1 times 4, write it here. Add. -1 times -4, add. -1 times 4, add. I double check my math there. How's that work?
Good.
So then we write the answer. Again, our first x in the original problem was x to the 4th. So we're gonna make it x cubed plus 4x squared, we just count down, minus 4x plus 4, minus 12 over x plus 1. Got it? Now, number 3, says find the remainder 2 ways, and they don't mean long division and synthetic division. One way of finding the remainder, would you agree with me, is to divide. However you want to divide, you'll get a remainder. So I'm going to do synthetic on this, and I'm going to divide and check out my remainder. I got 15. Did I do that too fast? I think that's right. 15?
Yeah.
Now, the other way you can find the remainder, you're not gonna, or maybe you already know this, I don't know. I think it's one of the coolest things ever. If I think of my original problem, x cubed plus 5x squared minus 8x plus 3, if I think of that as a function, and I plug in the number I would divide by, so in other words, -1 cubed, -1 squared, -1 plus 3. If I evaluate that, be prepared to have your socks knocked off. You're gonna get 15.
Uh-huh.
-1 plus 5 plus 8 plus 3. Oh my gosh. Not only can you get the remainder by flat out dividing, but you can also get it by simply plugging in the number that you would have divided by. And you might be thinking to yourself, okay, that's another one of those really cool, awesome things, Mrs. Ford, but how could that ever be useful? Well, I'd like you to think about this question. Now, what does it mean to be a factor? No remainder. It means it divides in evenly, right? So, could I do this division problem? Oh, I could. I love math, but I don't want to do that because what would that involve? A whole bunch of zeros, right? So instead of dividing, if all I want to know is the remainder, and that's all that matters, if I'm wondering if something's a factor, I only care, is there a remainder or not? I could plug in 1. That would be the number I would divide by if I were doing the division. So 1 to the 98th is 1, minus 17, plus 16 plus 1, that should be X there. 16 plus 1. What do I get when I do all that math? Is it a factor? No, because if it were, I would have done all that and gotten 0. Okay? All right. Now, go back to 2.3. Remember those problems we skipped because I got overly excited. And your job is to graph this. And our problem was, there's one like this on your quiz card. I'm going to give you a polynomial like this, and you're going to have to graph it. We just practiced one. What do we have to know? The factors, right? And how are we going to find them tomorrow on the quiz? We're going to factor by grouping. Okay, so now we're today, and we got this problem, and it is not going to group. Would you agree with me?
Yeah.
Okay, so I want you to think about what we've been talking about. We're trying to find factors. What does it mean to be a factor? It means when you divide, you get a remainder of 0. So we need to find numbers that we can either physically do the division and get 0, or that we can plug in and get 0. Remember we just talked about that? So you're going to start guessing numbers. And I know what you're thinking. You're thinking, this could take a very long time. Because there are a lot of numbers to guess from, right? So I'm going to narrow it down for you. I'm going to talk to you about what are known as the possible rational roots. Now this is the key word here. Right now, if I said to you, start guessing, find me a number that gives me 0, you have infinitely many possibilities. Right? There's infinitely many numbers. I'm going to narrow that down. For this particular problem, the PRRs, as we call them, possible rational roots, are factors of 55, factors of that number, and that would be plus or minus 55 and 1, or 11 and 5, right? Those would be the only possibilities. Over, so factors of this, over factors of that number, which is just a 1. Now that number could be a 2 or something. If it were 2, then you would have 2 and 1 down here. If it were 6, you would have 6, 3, 2, and 1 down here. So it's factors of that number over factors of this number. That's it, kids. So a minute ago, we had infinitely many options, now we have 8. 8 options. And your job is to guess one and either plug it in or divide. I don't care, do whatever's easiest for you, and you gotta get a 0. Alright, so you have, what's a guess? What's a guess?
5.
5. Let's try 5. I'm gonna go ahead and divide, but you can also plug in if that's how you wanna do it. So I get a 5, a -2, a negative 10. Oh, this does not look good to me. Is that gonna give me a 0 here?
No.
Let's try -5. I like 5. I think 5 might work, but so let's try -5. That'll be -12. That'll be 60.
Okay.
There we go.
Okay.
Life is good. We got a 0.
Yeah, you
It's a
did.
0.
So our first guess didn't work. Our second guess did, but it might not. If our second guess doesn't work, then we try a third. As long as we need to. Now, remember, we're trying to graph this thing. You just told me that if I divide by x plus 5, I'll get a remainder of 0. What is this other stuff? What's that?
X squared
X
minus 12x.
squared minus 12x plus 11. Does that factor?
Yeah. Yeah. X
X
minus 11.
minus 11 minus 1? Now you're factored and you can graph. Notice, are the other 2 zeros we got are 1 and 11 in our list of possibilities? Yeah, they always will be. Okay. All right, let's try G. Remember, we went back to 2.3, we're picking up these 2 problems. So tell me how we're gonna do G.
You gotta find the PRRs.
PRRs, possible rational roots. So that will be plus, oh boy, there's gonna be a bunch of them.
12 and 8.
12 and 8.
I like to do it like this, 96 and
48
1,
and 2.
2 and 48,
3 and 32.
3 and 32.
4 and
24.
Not 5, but 6.
6
And 16.
That's 7 and 8.
There's 8 for
9 doesn't go in, 10.
Oh, yeah, yes,
That's it.
it is.
That's it. There's a bunch of them.
This is still a quiz, right? Oh, you said this question was a quiz.
No, no.
No, she showed the ones that are.
There'll be an equation like this, but you'll group it. Yeah, so the quiz is over what was on the review sheet, the problem's identical. This is our next step now.
You're probably gonna get to this, but when you're finding the PRRs, when you take the first coefficient, so like in this case it'd be 1, do you do the factors of it, or
Yeah.
is you just, okay.
No, the
So just cause
factors
it's
of
1,
it.
it's
It
gonna
just
be
doesn't
1.
work.
But if it was like 4, it would be
4, 2, and 1. Yeah. All right. Now there are a lot of PRRs. I don't know. What do you want to start with? Maybe we'll try.
Negative 6.
6 is a big number.
Well, someone with 12.
Right in.
What if I needed 2? Actually, let's try positive. Alright, so here we go. Aren't you glad you listened to me?
What?
Now, here's the deal, folks. I'm ancient. I've done 17,000 of these, and still, a lot of times I'll have to guess 4 or 5 times. If you guess a number and you don't get a 0, no big deal. You guess another number. And you keep guessing until you get 0. Now, because of the arithmetic, I always start small. So like I would not think of starting with 32 because the arithmetic is just bad. You can start with whatever you want, that's up to you. But my strategy is always to start small. Now, don't lose sight of what you're trying to do. You're trying to graph this picture. Right now, you know you have an x-intercept at 2. This number right here, that's your x-intercept. That's the number that gave me a 0. Where are the other zeros gonna come from?
Right there.
The quotient, that part right there, which is x squared minus 2x minus 48.
Minus 8, x plus 6.
That factors into x minus 8, x plus 6. So where do your other 2 dots go?
8.
At 8 and negative 6. It is a regular, I didn't write down the problem, but it's a regular cubic equation. Nothing, I don't have any repeated zeros, no squares and stuff. So it's just look like that.
Where's the 2?
2 came from here. The 2 was the first one I found. That was my guess. Now, back when we were guessing numbers, the other 2 numbers that would have worked would have been 8 or negative 6. Not bad. All right. Back to page 26. You are not graphing. In problem number 5, we are done graphing, and we are just going to find the zeros. So in other words, for this one we just finished, we would find 2, 8, and negative 6. That's all we do for problem number 5A. All right, so here's one, Sam, that you were asking about. So my PRRs are going to be factors of 6, and never forget the plus or minus, but you only need to put it in once. You don't need to put it on the bottom also, because the top covers it. So plus or minus any of these numbers. Factors of 6 over factors of 2. Okay? Last over first. Alright? Now, I don't want you to worry about this because in a lot of cases it isn't even going to matter. But what that does for you now is introduces the possibility of guessing fractions. So, if I put these over 1, then my guesses would just be 6, 3, 2, and 1. But if I put them over 2, now 6 over 2 is 3, but now I could have 3 over 2 or 1 over 2. Now, no one ever guesses the fractions first. I'm going to try to guess the non-fractions, and if I run out of those options, then I will have to go to the fractions. Now, that's my stuff. You do it however you want. This is your list of possibilities. Okay? So, let's try, 2. I like 2. 2 works a lot. So 4, 1, 2, not this time. Not this time. You want to try what?
Try negative.
Negative 2? Why not? Really?
Let's try 3.
Alright, we'll try 3 if this doesn't work.
I like 3.
This one.
Yeah, no,
So you want to try 3?
Let's try 1.
One at a time. We'll try 3. Then we'll try 1.
no, not like that, not like that.
Oh, you are not
Let's try 1.
It's not negative 3. No, yeah.
Negative 3, negative 3.
What do you put negative 3 in? Those are yours.
Let's try this at
Negative 6. It might be 6.
Pull the fractions.
Oh, whoa, whoa.
Heck
Oh,
no.
no.
Oh my
God.
Heck no.
This is 4.
Negative 6, negative 6.
It might be negative 6. Rip a negative 6. It might be negative 6.
No.
Not that too, guys.
No,
It's just
Yeah.
not. No.
How's it gonna work?
Wait,
No,
did you
keep
go
going,
in
keep
for
going,
negative
keep going.
3? Did you do negative 3?
You stopped way too
I
early.
can't remember. Did I?
Did you do negative 3?
Did I try
3
negative
over
1?
2.
No.
Yeah, you did.
Don't even try negative. Negative 3 is wrong, so even try.
No, it's not.
Start negative 3.
Negative 3 is wrong. It's wrong.
Just say it's no solution.
I mean, start your wife
Alright, I'm gonna try 1/2.
Oh.
I don't want to do this, so I'm going to. So that's gonna give me 1.
Uh-oh.
That's gonna give me
Negative.
negative 1.
Uh-oh.
Nope.
Negative 1.
No.
Oh my god. 3 over 2?
I like it.
Oh.
What if this happens with a test? We're gonna run out of time.
If this happens, then you run out of time.
That's so unfair.
Save these for last.
What'd you say,
What are we
3
doing?
halves?
Try negative
3 over 2.
Negative 3 times.
I still didn't see negative
I said that earlier.
I didn't do negative 1 yet.
Your guess is wrong.
You got negative 1 half.
So you just have to get the test or
You
not?
got-
Oh.
we have
already
Oh. Wow.
Yeah! I said that.
Good job, guys.
That was my guess. I said that.
I'm lucky, I'm standing up here at the board, I
taking
just
credit
right
for it, yeah.
away, you used up a sheet of paper, getting to this point. But perseverance, you just keep on guessing until you get one that works. So, one of my answers is 3 halves, that guy right there. Where are the other 2 coming from? Right there. Quotient. And my quotient is 2x squared plus 4, or minus 4. 2x squared minus 4. Actually, I don't think I take 2 out. But does that factor? Okay, now remember, we're solving it, so we want to know, we want to set it equal to 0. So, can I divide both sides by 2? And take the square root of both sides. So what are my other 2 answers? Plus or minus the square root of 2.
Oh.
Now, here's the deal. The reason this problem was so, like, we went on and on, guessing, is because our list is the possible rational roots. Look at our answers. We have 1 rational root, but the other 2 are irrational. So we couldn't have guessed them because they're not in our list. So we just had to keep going until we finally found the rational root. In real life, there is no guarantee that any of these will work. in this class, at least one of them will always work. So you need just to keep going until you find it. Okay? All right, let's try one more. I think we can do one more. This one I think will be a little easier. First of all, this one ain't gonna have any fractions because why? PRRs are factors of 6 over factors of 1. So what shall we try?
Try 2.
2? Two didn't work. Oh, somebody found one. All right, let me keep going in case, that's gonna be 2. That's not gonna be- Oh, what did you say works?
Negative 3.
Negative 3.
That was all me. Okay, yeah. That was the bottom.
Yep, it sure does.
Easy peasy.
So one of your answers is negative 3. Where are the other 2 coming from?
Quotient.
Right here, x squared minus 2x minus 2.
Back.
Oh,
Let's get some quadratic.
Charles says, well, factor, but then he says, ooh, I need a quadratic.
Quadratic formula.
I like that.
Owners use last don't joke.
It's on Monday, math league on Tuesday.